Okay, so now we're on number 14. And on this one, the question is, what is cosine -1 of 1? So cosine -1 of 1 is 0. So sometimes you luck out and get an exact answer like that. Sometimes you might have to get it in terms of pi. What it means is at the point 1, 0, it's 0 radians. And it's saying, what is the angle? What is the angle when cosine x equal 1? So basically, you look for your cosine value of 1, and then you can see it be 0 radians. Okay, number 18. This time you're going tan -1 of -1. And this is where you're going to get a decimal if you do this through the calculator. It's -0.785 something. So we can't answer it that way. On mine, I can see it's pi fourths, but on y'all's, you'd have -0.78539, so forth. And so what I would recommend doing is making a reference table like we did before. And basically pi 6 is 0.523. Pi fifths is 0.628. Pi fourths is 0.785. Pi thirds is 1.047. Pi halves is 1.57. And pi is 3.14. So all these are rounded, but if you recognize the first couple of digits or couple of places, then you can find it. Like 0.785, well, that's right here with pi fourths, and so we just want -pi fourths. The other part, which we talked about last time, was your interval for tan -1 is from -pi halves to pi halves with parentheses because of the asymptotes. And so, like, if you want to think of it like -1/2 to 1/2, 0 in the middle, 1/4, and -1/4. That's how I would relate it using number sense to knowing it goes -pi halves, -pi fourths, 0, pi fourths, and pi halves. So, in other words, these are the values in the interval. And so -pi fourths does fall in our interval, so you know that it would work. Any questions about that? The other thing to think about, tying it into what we've done before, is if tan is -1, I'm going to put theta here. tan theta is -1 when the x and y values are the same, which is 3 pi fourths, except for one of them being negative. So 3 pi fourths as well as 7 pi fourths. Now the problem with using the unit circle in that case is both 3 pi fourths and 7 pi fourths are outside the interval. And so you have to use the coterminal to 7 pi fourths, which is just negative pi fourths. Any questions about that? Okay. 22. Sine -1, negative square root of 3 over 2. So on the calculator you get -1.047, which if you use your table, it's pi thirds, except it's going to be negative. So remember, your sine interval is negative pi halves to pi halves. Our sine -1 interval is -1 to 1. Think about the best way to word this. Okay, so from our notes, when we were talking about sine, we had negative pi halves to pi halves. That's when it was sine -1 on the outside, and then the sine on the outside was -1 to 1. So, okay. Anyway, you use your calculator and you find it's negative pi thirds. And again, if you use the unit circle, look where the y value is equal to negative square root of 3 over 2. So that's at 4 pi thirds and 5 pi thirds. And those are outside the interval. And so then we just go negative pi thirds instead. You can kind of get it from knowing your denominator is 3. Because 5 pi thirds and negative pi thirds are coterminal. Okay. Okay, so the next couple of questions, just rely on the calculator. And it says round to 2 places. And make sure on this you're in radian mode. So for the first one, you have cosine -1 of 0.6. And so you do this on the calculator and you get 0.927, so that's 0.93. Number 30, you have sine -1 of 1/8, and so that's 0.125, so 0.13. And 34, cosine -1, -0.44. That's 2.026, and so we want 2.03. Okay, so now on these next ones, you need the exact answer instead of the calculator answer. So 38 sine -1 of sine of -pi/10. So as I was mentioning earlier, the sine -1 interval part was -1 to 1, and this interval part is from -pi/2 to pi/2. And you've got to work inside out, and so you need to be in range, in the interval, basically. Okay, so when you do this one on the calculator, I think you're going to see something a little familiar. Sine -1 of sine of -pi/10. Alright, so you might recognize some of the numbers on here. 314,159, that's kind of like pi. Whoops, as a decimal. 3.14159. And so basically you could probably guess it's -pi/10. Because all you're doing is moving your decimal place over by 1. So sometimes on this you're going to have the exact same value as what's on the inside. Sometimes it's going to be a different sign, and then sometimes we just have to use the same denominator and figure out what the coterminal would be. But on this one we just want -pi/10 because it was basically -0.314159 something, which is in the interval from -pi/2 to pi/2. It's just pretty close to 0. Okay, 42. This one we have cosine -1 of cosine -5 pi/3. And so let me guide you through this process. Guess -5 pi/3. Guess 5 pi/3. I don't think either one is going to work for our answer. cosine -1 of cosine of -5 pi over 3. It's 1.047, and so we know it wouldn't be the positive, so now is 5 pi thirds related to this? No, because that's 5.23. And so then what you notice is your denominator was 3, so how about we just try pi thirds? And that actually matched our table, which said pi thirds 1.047. So that is going to work with pi thirds 1.047, which is exactly what we want. So our answer is pi thirds. Okay, so again, for extra understanding, this is what it really means. You have cosine of -5 pi thirds. So what you want to do is find your 5 pi thirds, which is right there, and then flip. So it's right there at pi thirds. So find 5 pi thirds and then flip to pi thirds. And so that ordered pair would be 1/2 comma square root of 3 over 2. And so if you're doing inverse cosine of 1/2, then you're going to get pi thirds. So this is like a lot of extra work. You don't really have to do if you don't want to. But this is like a deeper understanding of it. They could have you take steps, like find out where cosine -5 pi thirds is, which is at the pi thirds, and then look at the ordered pair for it, and then do inverse of that, and again, that's your pi thirds. It's all circular and related. So that's a way to check your answer. The easy way is to just get the decimal and then figure out which of these it is. Okay, 46. This time you're doing cosine of cosine -1 of -2/3. So again, I would guess, is it -2/3 or +1/3, or I really meant +2/3. So let's find out. Cosine -1, -2/3. Okay, it actually gives me -2/3, and so that was right. So that does fall in our interval that we want. In this case, it was the interval -1 to 1. So -2/3 is in that interval. Okay, number 50. This time we're doing sine -1 of -2. So the sine interval, like we said earlier, is -π/2 to π/2. This interval should be from -1 to 1. But we got -2. And so this is not in the interval. So let's look at what type of error message we get. Sine -1, -2. It just says undefined. When I did this last year, it said non-real calculation. Let's see if I can get that to show up. Sine -1 of -2. Okay, see, like on y'all's calculators, it says non-real calculation and some other stuff. And on mine, it just says undefined, but it means the same thing. So if you see it says non-real calculation, then that's the same as undefined. Any questions? Okay. Now we have a couple more that have to do with actual intervals and moving things. There's actually lots of steps. You want to find your inverse and your range of f and your domain and range of f -1. Okay, so to start with, the problem on 54 is y equal 2 tan x minus 3. Y equal 2 tan x minus 3. And so just like we did before on inverses, you want to switch x and y. So x equal to tan y minus 3. And then you want to solve for y. So add 3 to both sides. And then divide by 2. So that's what our y is. Oh, I didn't finish. So my 2's cancel, and so now I have tan y. So tan y equal x plus 3 over 2. To get rid of tan, we have to do inverse tan to both sides. So we have tan -1 of tan y. So these cancel. And we have tan -1 x plus 3 over 2. Basically, we're trying to get the y by itself. And since it was tan, we have to do inverse tan to both sides. So we have y equal tan -1 x plus 3 over 2. And so that's our inverse function. I'm going to put f -1. Now, I would just want to mention a couple of things, like this one was multiplying by 2 in the original, and so here we're dividing by 2. And here we're subtracting 3, and here we're adding 3. So if you want to think of it that way with common sense, you can. But it is like dividing the whole thing by 2, not just dividing the first half by 2. Okay, so now let's think about our domains. So for the function f, which is the y equal that, the domain on that is all real numbers. We're going to start with all real numbers, but then, well, except for the multiples of pi halves, because that's where the asymptotes are. And so then we need to reduce it to negative pi halves to pi halves. And then the range of the original function is all reals. So these are for f. Then for f negative 1, the domain would be the same as the range of the other one, which is all real numbers. And then our range would match up with this negative pi halves to pi halves. So again, notice these two go together and these two go together. Any questions? Okay, then 58. On this one, we've got a couple more transformations we're doing. So cosine x plus 2, which means left 2, and we're going to do plus 1, which means up 1, and that our middle is y equal 1. So we want our inverse, so we switch x and y. X equal cosine y plus 2 plus 1. And then bring this over, so it's x minus 1 equal cosine y plus 2. So here you can't move your y plus 2 yet because it's attached to the cosine. So this is where you do inverse cosine to both sides. So you have cosine negative 1 of x minus 1 equal y plus 2. Then just subtract 2. So cosine negative 1, x minus 1, and then minus 2. And that's your y, which is your inverse function. So we're basically switching x and y and solving for y. Okay, so let's think through the domain and range of this one. So for the domain of a cosine function, you're going to start with all reals, and then we need to reduce it to 0 to pi, because that's what our regular interval for cosine is. But in this case, we're going left 2. So next we get negative 2 comma pi minus 2 because of the transformation. So that's our domain answer. So cosine was wavy. It's all real numbers, but then we reduce it to 0 to pi. But then because we're going left 2, that means change this one left 2 and change the pi to be left 2. So that's how we get -2 comma pi minus 2. Okay, and then the range, okay, this is the f function. We have a middle at 1, and our amplitude is 1. So normally we would go from -1 to 1, but now we're going to go up 1, and so I'm going to say next do 0 comma 2 because we went up 1. So that's going to be our answer. 0, 2. And then for f -1, our domain is going to be 0 to 2 because these match. And our range is going to be -2 to pi minus 2. Okay, now I'm just going to graph that and see if it makes sense. So we have cosine x plus 2 plus 1. Okay, so it's wavy, but we needed to reduce it to -2 to pi minus 2. Okay, so there's that part, and then our range was from 0 to 2. Okay, so this passes our horizontal line test because none of the places hit in more than one spot. So that's our good graphing window for the function. Now when we do the inverse function, that's going to be cosine -1, x minus 1, and then minus 2. So that part is shorter. It's just basically going from 0 to 2 because those matched. And then our range would be from -2 to pi minus 2. Okay, so that's going to be our stopping point for today. We'll continue with 62 next time. There's only a couple more problems, 62, 66, and 76.